Dear friends, welcome to the next problem of belt drive, problem number 15. The data of the problem is like this. The smaller pulley of a flat belt drive has radius of 220 mm and rotates at 480 rpm. The angle of lap is 155 degree. The initial tension in the belt is 1.8 kN and the coefficient of friction between the belt and the pulley is 0.3. Determine the power transmitted by the belt. Friends, let us list out the given information in the problem. Here the radius of the pulley is given 220 mm, hence diameter of it will be 440 mm and that is equal to 0.44 meter. Speed of the pulley is given n is equal to 480 rpm. Angle of lap theta is equal to 155 degree. Hence theta is equal to, converting into radian, 155 into pi upon 180 is equal to 2.70 radian. The T0 initial tension is given 1.8 kilonewton, that is equal to 1800 newton. Coefficient of friction between the belt material and pulley is 0.3. We have to calculate the power transmitted by the drive. We know that the power transmitted by a belt drive is given by P is equal to T1 minus T2 into speed of the belt. Here we have to calculate T1, T2 and V. We know that the initial tension in the belt is given by T0 is equal to T1 plus T2 by 2, means average of tight side tension T1 plus slack side tension T2. Hence T1 plus T2 is equal to 20, and on substituting the value of T0, that is 1800 Newton, we found T1 plus T2 is equal to 3600 Newton. Let us say this is relation number 2. We also know that the ratio of two tensions, tight side tension to the slack side tension T1 upon T2, is given by e raised to mu theta. Upon substitution of values, we found is equal to e raised to 0.3 into 2.70. And so T1 upon T2 is equal to 2.25. So T1 is equal to 2.25 T2. Using this value in relation to, we can substitute value of T1 in relation T1 plus T2 is equal to 3600. That gives us 2.25 T2 plus T2 is equal to 3600, and rearranging terms and calculating, we found T2 is equal to 1107.69 Newton. Hence, the value of T1 is equal to 2.25 T2. Upon substitution value of T2, we find T1 is equal to 2492.3 Newton. Now, we also know that the velocity of the belt is given by V is equal to pi dn divided by 60. On substitution of values, that is pi into 0.44, that is diameter, into speed, that is 480 divided by 60, velocity of the belt V is equal to 11.06 meter per second. Now using relation 1, that is P is equal to T1 minus T2 into V, we found is equal to, substituting T1 is equal to 2492.3 minus T2 is equal to 1107.69 into V is equal to 11.06. So power transmitted P is equal to 15313.78 watt, so is equal to 15.314 kilowatt. So we can conclude the power transmitted by the belt is 15.314 kilowatt. Thank you, dear friends.